Good day to you all. Evan Snowman here for Umehluko. Today we look at the seventh video of the calculus series, looking at the remainder and factor theorem. Now, whereas this theorem fell into disfavor for a couple of years, it is back in the syllabus, not as a major topic, but as a topic that allows you to factorize cubics. Now, again, what's going to come out as a key idea in today's lecture is that a solution to an equation. Okay, so a solution to an equation is the same idea as a factor, or is linked to a factor of this idea is linked to the x-cut of the graph. Okay, so again, please watch out for this idea that the solution to an equation is the same as a factor is the same as the idea of the x-cut of a graph. Now, the key idea in the remainder and factor theorem is that if I was to have a function, let's call it f of x equaled, I don't know, ax cubed plus bx squared plus cx plus d, that if I was to sub into this value, a particular value, let's call it, I don't know, p, that if I substitute this value in here, a of p cubed plus b of p squared plus c of p plus d, and if this thing came out as naught, specifically if it came out as naught, we would know that therefore we had a solution of x equals p, but as a result we'd also know that x minus p was a factor, and we would know that x equaling p was a x-cut, an x-intercept. Okay, now this does not surprise you so much, okay, but the key thing is that if we've got f of p, let's just choose a different value, let's choose f of q, and we did all this with it, and we did not get 0, i.e. this would therefore be not a solution, but importantly not a factor, we would realize that that this would not be a useful value for the rest of our sum. But again, we're going to pull out something which we've never really, what you may not have thought about from your junior grades, and that is that when 3 goes into, for example, 21, it leaves no remainder. So when 3 is a factor, it leaves no remainder. When 3 goes into 22, we know that it doesn't go in entirely because it leaves a remainder. Okay, 3 times 7 plus 1 equals 22. And so because it leaves a remainder, it is not a factor. Now, what it turns out is that this value that we're getting out over here actually is remainder. And what we're saying here is that if this remainder equals naught, then we have a solution, a root, a factor, or an x-cut. When this value does not equal naught, we have nothing. Okay? We simply know it is not a solution or a factor or a root or any of these options that we have here. Okay, so what I want to do now is to look at 3 types of questions. Each of these questions is incremental on one another. I found them all in past exam papers. The first 2 are quite straightforward, and the last one, as you'll see, is a little bit more interesting. Okay, factorize this crazy thing. Okay, so we don't know how to factorize this thing initially. 36 has got many factors for us to try. It's not a great option. The presence of the 2 over here is not great. So what we're going to do is we're going to say, let this thing equal y. And again, I know that we could factorize this thing on the calculator. I know that some of you guys possess some of the fancier calculators. I'm working on the premise that you don't. So what we're going to do is we're going to choose a value to work with, and let's try 1. When we do that, y equals 2 minus 5 minus 21 plus 36. And the key thing here is that this does not equal 0. We can try 2. Y equals 16 minus 20 minus 42 plus 36. And again, I'm not overly fussed about the answer. The key thing about it is whether or not it equals 0. Okay? What I'm going to try now is, hopefully I've done it correctly. And if I try 3, again, quickly checking something. If I try 3, I'm going to get y equals 2 times 27, so that's 54, minus 5 times 9 is 45, minus 63 plus 36, again, equals 0, does not equal 0. But when I try x equals 4, and again, sometimes all we need to do is persevere and take a little bit longer, okay? And we're going to get y equals 2 times 64, which is 128, 5 times 16, which is 80, 21 times 4, which is 84, and 36. And the key thing which happens here is that this does, in fact, equal 0. Okay? And so that is telling me that I now have a solution, a root, a x-cut. Okay? So what I now know is, therefore, x minus 4 is a factor. Okay, and again, I'm assuming that you know how we got from the root to the factor. Okay, so as a result, we now know that 2x cubed minus 5x squared minus 21x plus 36 is equivalent to x minus 4 times a second factor. Because we originally had a cubic and we now have a linear factor, we know that the second bracket will need to have an x squared term, an x term, and a constant. Okay, again, if I was to pick the 2x cubed, okay, we would know that comes from x times x squared, which tells me that I know that this has to be a 2. Okay, if I was to look at the 36x, sorry, the 36 constant, that would come from the 4 times the constant, minus 4 times the constant. So I would know that minus 4 would need a negative 9 at the back end here. Okay, and I've now got my outer two terms. Okay, so I've achieved two of my goals already. Okay, I'm now going to choose one of these two, just to be different from the previous example. On a previous lesson, I'm going to choose the x squared term this time. To get x squareds, you need x times a number, sorry, x times x, or a number times x squared. I want to have a sum total of minus 5. Currently, over here, minus 4 times 2x squared is giving me minus 8. So I want minus 5 of them, which means this has to be plus 3 of them, which means that I need to have, hold on, x times what gives me 3x squared. And hopefully you're going to realize that this needs to be plus 3. Now I know I'm doing it by inspection, but that for me is the most efficient way to do it. Takes up the less space and takes up the least amount of time, unless you are the proud possessor of the fancy calculators, which unfortunately are quite pricey at the moment. So again, I wouldn't be surprised if you are following my example here and trying to do it by hand. I now need to complete the factorization. So that equals x minus 4. 2x squared is going to become an x and a 2x. A 9 is going to become a 3 and a 3. I need to end up with plus 3, so it's going to be plus 3 over there and minus over there. Please note that I don't need to go further. I have got my three factors. There is my first factor. There is my second factor. There is my third factor. If they did ask us to solve it, we would go one step further. We would make this thing equal to naught, and we go the one step further of x equaling positive 4 minus 3, or positive 3 over 2. But we do not need to in this particular question. So again, this is a lovely question for just reminding you to answer the question. Make sure you get to the point of answering the question, but also make sure you don't go too far or go further and then make unnecessary mistakes by going on into unnecessary work. Okay, as I said, factorizing is one form of the question. Solving for x is another form of the question. Again, I like this. I've always liked this particular example because it has a missing term. And so some people think this is a quadratic. Please note that this is a cubic because it is x cubed, not x squared. So it is easy to mistake this one for being a quadratic equation when actually it is a cubic equation with a missing second term. Okay, so we need to factorize this thing. We're going to do the same thing. We're going to say okay, so let's have a look here. Let this thing, let y equal x cubed minus 13x plus 12. And the good news is that if we let x equal 1, we're already going to get 1 minus 13 plus 12, which equaled 0. And so in this particular case, although the sum looks slightly worse, it was actually quite easy because the first example we picked already gives us one of the solutions. So we then know that x cubed minus 13x plus 12 equals x minus 1. Okay, having got a solution, we also have a factor. We talked about that tension between a solution and a factor. Okay, how these two things are interlinked. Okay, again, please notice I'm leaving a bit of space here just so you're reminded that this is actually a cubic with a missing term. Okay, again, I need to look at what is going to be in the other bracket. Again, following on from what we said previously, I should realize that there's going to be a x squared required. That the minus 1 to get to positive 12 from multiplying, I need to have a minus 12. And what I'm really looking forward right now is this middle term. Okay. And again, just to make a point, I'm going to choose to do a slightly different method this time. I'm going to choose to put a value in here. Okay. I'm not going to do it totally by inspection this time. I'm going to do it a slightly different way for those of you who like writing things down, who like doing things using algebra. So I'm going to put an a over there. I'm now going to multiply that out. So I've got x cubed plus ax squared minus 12x minus x squared minus ax plus 12. And what I now want you to look at is I want to compare coefficients. I've got my x cubed. I've got my plus 12. I'm going to choose either the x squared position or I'm going to choose the x to the power of 1 position. And I'm going to do what we call compare coefficients. Okay, my favorite number is a 2, so I'm going to choose, for this case, I'm simply choosing it. I'm going to choose to look at the x squareds. So when I look at the x squareds, the coefficient of this thing x squared is no x squared. So if I'm looking at the x squareds, on the left, I've got none of them. On the right, I've got ax squared minus x squared, so a minus 1. Therefore, I can realize that 1 equals a. Just for those of you who are paying attention, I'm going to do it quickly in yellow. If I did it for x to the power of 1, if I did it for x to the power of 1, I'd have minus 13 equals minus 12 minus a, and again I'd get that 1 equals a. Sometimes I actually like doing it both methods because again getting the same value tells you you must have done it correctly. So now we need to proceed with solving the equation. So we now have x minus 1 x squared plus 1x minus 12 equals naught. Please don't forget that this actually is an equation equaling naught. So we now have x minus 1. If you factorize that other trinomial, so x plus 4, x minus 3 equals naught. Therefore, our three solutions are x equals 1, x equals minus 4, or x equals positive 3. And we have gone and solved for x. Now, I keep saying that a root is a solution, is a factor, and here is an example of that. They've given us this is the third type. We're not being asked to sketch the function. We're not being asked to find the equation of the function. They've given us both the sketch and the equation of the function, and they're asking us to find out some features of it. Okay, so what we need to know is, okay, that A, B, and C are on the x-axis. That means they are x-cuts, x-intercepts. D is on the y-axis. It is a y-intercept. G and E are the local maximum and local minimum, so they are stationary points. And F is vertically above point E on the x-axis. It is directly above point E. Okay, so find the length of AC. Well, A and C are x-cuts. So what we need to do here is we need to go and make y naught. So naught, to find x-cut, we make y equal to naught. So naught equals x cubed minus 4x squared minus 11x plus 30. Okay, I need to do this fairly quickly, so let's see what we can do here. Okay, so if we tried 1, it wouldn't work. If we tried 2, it might work. So let's try 2. Okay, so 2 cubed, which is 8, minus 4 times 2 squared, which is minus 16, minus 11 times 2, which is minus 22, plus 30, plus 30. I'm getting 38 minus 38, which does in fact equal 0. Okay, so I know that naught equals x minus 2. Because x equals 2, I substituted in x equals 2. Because I've got x equaling 2 being a root, I know that x minus 2 is a factor. I need to get x squared. To get x cubed, I need to have minus 15 in combo with minus 2 to get plus 30. I've got minus 2x squared, so I need a minus 2x to get minus 4x squared. I'm going to get naught equals x minus 2, x minus 5, x plus 3. So I'm going to realize that my x values are 2, 5, or minus 3. But I would like you to look at the position of these letters on the graph and to realize that B is the middle value. So this is the x value at B. 5 is the right-hand value. So that is the x value at C. And therefore, minus 3 is the x value at A. And as a result, I should be able to realize that therefore the length of AC is going to be 8 units long. From minus 3 on the x-axis across to 5 on the x-axis is 8 units in length. Okay, over here I'm being asked now to find the length of EF. EF is a vertical length, so it is therefore involved with y values. Okay, so vertical length, so it must involve y values. We know that at F, it will have an x value, but the y value will be naught. And at E, it will have the same x value, but it will have a y value. And that is going to help me find this idea. E, as you said, is a local minimum. So we are going to therefore find the derivative f prime equals 3x squared minus 8x. This is similar to one we did before, minus 11. Therefore, and to get a stationary point, we make that equal to naught. So we have 3x and x. We have 1 and we have 11. And as a result, it was minus 11 over 3, was it? No, it wasn't. It was plus 11 over 3 and minus 1. Get to minus 8. No, it's not. It's the other way around. Okay. So what we have here is x equals minus 1. Let's actually do it the other way around. Okay. X equals 11 over 3 or minus 1. Again, okay, we should realize that this is going to be the x value at f, at E or F, and this is going to be the x value at G, just because of its placement. Minus 1 is to the left of 11 over 3. We now need to find a y value, so we plug it in. So y equals f of 11 over 3. I won't lie, I've always found this version to be slightly easier to do, is to actually plug it, instead of plugging it into the original equation, is to plug it into the factorized version and to see what happens. So it is 11 over 3 minus 2, 11 over 3 minus 5, and 11 over 3 plus 3. Well, 2 is 6/3, so this will be 5/3. 11/3 minus 2 is 5/3. 5 is 15/3, so we're going to have minus 4 over 3, and 11/3 plus 3 is going to be 20 over 3. So if I do this sum quickly, 5 times 4 times 20 is 400 over 27. Please don't forget that minus sign is floating over there. Okay, so we now know that the y value at f is naught. The y value at E is minus 400 over 27. And therefore, we know that the length of EF is going to be the positive value, because distances are always positive, is 400 over 27 units. Okay, I want to do the last one quickly, which is again just a quick freebie. We are being asked to find the gradient at B. To find the gradient at B, we need to know the x value and we need to know the gradient. Please notice that to find the x value, to find the gradient at B, where they're saying we need to find, sorry, quickly picking it up here. Okay, no, not at all. Just saying to find the x value at C, to find the gradient at C, we need an x value and we need a gradient. But again, what I'm trying to point out here with these sculpted questions is, please don't forget that over here we've got the x value at B that we require, and over here we've got our gradient. So all I'm going to do here is use these two pieces of information that I found, one in part A and one in part B. So this is quite easy. Our gradient is going to be f prime of 2, which is going to be 12 minus 16 minus 11, which is minus 15. And so this was almost like a little free cherry, just saying, thanks for doing all the hard work earlier. Do you realize what it is that you've been doing? And gave you a little bit of free marks towards the end of what's been quite a difficult question. Okay, thank you very much for your time. We'll hope to see you soon. All the best.